Hi guys, it's me, I'm Lena, and in this video I'm going to be talking about the third edition, which is on fractions, decimals, and percentages part 2. Now in this video I'm going to be talking and continuing on the topic of fractions, decimals, and percentages. So all of these problems will be related to these three topics, and also there will be some applications, some problems that will apply math in healthcare as well. So let's get started with the first part. The first problem states that 345,607 is 5 more than a multiple of 8, or 345,607 minus 5 will equal, well, I have the answer of 345,602. So to make this number a multiple of 8, we need to find what is n. And what is the divisibility rule of 8? Well, the last three numbers needs to be divisible by 8. So let's put in some numbers. How about 612? No, that cannot be divisible by 8. Next we have 622, and that does not apply either. 632, well, 632 is divisible by 8, because if we take 632 divided by 8, 63, 7, 8. Yes, I would be 7, 56, 7, 2, 9. So that will be 79, and there is no numbers left. There are no remainders. Next, we just move on and on until we get to a number that is actually divisible by 8, that has no remainders. So there are only two numbers in here, 3 and 7. So my answer, n, equals 3 and 7. Moving on to the next problem, problem number 2. Problem number 2 says that what are relative prime numbers? And also, please give an example of relative primes and how we use relative primes in medicine calculations. So firstly, let's answer the first problem. What is relative primes? Now, relative primes, also called coprimes, are two integers that have no common factors except 1. Now let's take an example. This is also the second problem. 5 and 3. Let's find the greatest common factor, GCF, or greatest common denominator. Okay, so greatest common divisor, I mean. So 3 and 5 will the GCF of 3 and 5 will equal 1. That is the common factor of 5 and 3. Another example is the GCF of 8 and 9. So that will equal 1, and nothing except 1. So yeah, that is coprimes. These two numbers are coprimes or relative primes. Next, the third question asked that how do we use relative prime numbers in healthcare and medicine calculations? So I've done some thinking and also done some research, but I can't really think of some medication or medicine healthcare calculations that are directly linked to relative primes. But there are some indirectly linked things, indirectly use applications of coprimes in healthcare, such as like help with the math tools, math techniques, used with statistics, research, data analyzing, all those kinds of things that are related to healthcare, because that helps with the effectiveness of the vaccine, how does it spread, how does the disease spread over time, and analyze things like that. So it's indirectly used. It's not commonly used in medical practices like procedures, surgeries, or any kinds of things like that. Okay, so yeah, that is done with the second problem. The next problem, the third problem, is prove that A times B divided by A equals B. Now, there are two ways that we can prove this. One, take an example, or two is the simplest way. We can present this in another form, in a fraction. A times B, in parentheses, divided by A will equal what? Now, we know that these two cross out, and there will be B left. And that is the easiest one. But let's take the second one, an example. So we know that A times B divided by A, let's take 2 times 1 divided by 2. So 2 times 1 is 2 times 1 is 2 times 1 is 2, and 2 divided by 2 is 1. So 2 is A, 1 is B, 2 is A, 1 is B. And that is the second way of proving that A times B in parentheses divided by A will equal A times B over A. Okay, so yeah, that is for the third problem. Let's continue with the 3.1, the problem 3.1. So problem 3.1 says that suppose X. I'll give you the problem here. Suppose that X is your original number, which is given that X milliliters of urine was produced in 30 minutes. What is the rate of urine formation in milliliters per minute? Please show the rate in this box. So those are my answers, and now we're going to be solving problem A and B. Now for problem A, let me see here. Problem A. If X equals 250 milliliters, the rate is what? Okay, so we have, let's see, 25 milliliters. Okay, we have X. Okay, the formula minute. So we know that the amount of time is 30 minutes. And if X equals 250 milliliters, so this will equal 25 milliliters per 3 minutes. But I want to simplify this down even more. Now, this will round up to approximately 3.3 milliliters of urine per minute. Okay, so that is my answer for problem A, 3.1a. For 3.1b, if x equals x over 1 over 5, the rate is, so the rate I found, x milliliters per 6 minutes. So we'll take x here is 30 divided 30 over 1 over 5 is 30 equals 6 divided by 1/2. Okay, so that equals 6. That is my answer for problem B. Problem B, 3.2. So for the problem 3.2, we won't do much. It's just how many times the how many times is 0.5 milligrams larger than 0.05 milligrams? Now, this is relatively easy. So to find the number of times, we can take we can just see the number. There are no zeros here. There's an actual 0 here. So this is larger than this 10 times, because here we will move here 10 times. Or we can take 0.5 divided by 0.1, 0.05. Let's take this, will equal 10 times. Okay, so that is my answer for problem 3.2a. For 3.2b, liquid medicine and injection dosages are rounded to the nearest 1 decimal place tenth. If the amount exceeds 1 milliliter, please give some examples. So the medication, to simplify this problem, medication dosages and injection dosages are rounded to the nearest 1 decimal place, tenth. And let's take an example. Here, 14.05 will equal what? Well, we know that the 10th decimal place is here. So we'll look to this. If the number is smaller than 5, then we'll round it to 14.7. But let's take another example. If this 8.17 will equal what? Now, in this case, the number next to it is larger than 5. So we'll round to the next number, which is 8.2. So that is 2 examples. But what if it's exactly 5? Well, we just apply the formula. This will equal 7.6. So any number that is smaller than 5, it will be rounded to 0. But when it is larger than 5 or 5 itself, it will be rounded to the next number. So yeah, that is for this problem. Next, we have also this example and this example too. So those are all of my ideas and also my answers for this video and this D3. I hope that you learned something new from this video, or you can point out any mistakes that I've made or any other improvements that I need to make. So thank you again for listening to my video, and I hope you to watch again some of my videos and also give me some feedback on it. So thank you and goodbye. See you again.